Welcome to another video from Lockdown Electronics with me, Bill, and this time we're going to take a look at this Gochifix Scope Meter, which has been sent to me for review by Banggood, and I said I was happy to review it providing I could was free to say whatever I wanted about it, which they were more than happy with. So let's go straight to the bench and have a look what it does. Okay, so here we are then with the Gochifix multimeter and oscilloscope, and it's actually nice and compact, got a fairly solid sort of soft plastic case, so it feels quite rugged actually. Here we've got a USB-C, if I can just undo it that'd be even better. USB-C there for charging. It's got built-in rechargeable battery. We've got a stand there which allows it to stand up in the conventional multimeter sense, and I think first thing to say is that you know, this is, in my world, this is a cheap and cheerful meter, and I realise people are going to be critical of this and say it's you know, it's not as good as a fluke this or a fluke that or whatever, and no, it probably isn't, but I'm of an age that when I got going in electronics as a teenager, I actually had this. It doesn't work very well anymore, but that's not surprising. It's probably 50 years old, and I bought that from Maplin. Actually, I was going to say Tandy. Bought that from Maplin in the 1970s, and I mean, it's got a logarithmic resistance scale on here. So the higher the resistance, the less accurate the ability was to read the needle. But this was fine, and I used this for years and years without any great problems. And if I'd have had access to something like this, it would have just been jaw-dropping. And I guess this was about, I don't know, between 10 and 15 pounds all them years ago. So if you want to do the maths, it's probably a similar price for this. So yeah, we've got oscilloscope, multimeter, and it's got all the normal sort of settings on it really. I think it's probably also fair to say it comes in quite a nice little pouch. It has a USB-C charging lead and excuse me, a pair of probes, which the kind of probes you'd expect with a meter of this kind of price point. They're not nice silicone ones, but they're perfectly okay for what they are. Nice little printed manual. I have to say it seems fairly readable, and what I particularly like is it's got this simple operation sheet that's come with it, English on this side and what appears to be German on that side. Yeah, it is German, and you could probably get away with just that for a bit of a manual, because it talks about all the various the modes and how to get in and out of things. So the manual itself is that this one's fully in English, and there's plenty of pages. So yeah, that's actually quite impressive really. So switching on, comes up with automatically boots into wherever you click it to. In this case it's voltage. It's showing you the state of charge of the internal battery there, and then we've got your usual 4 connections here. Most of the multimeter readings are going to be taken with these two. That's with common, that's obviously volts, ohms, etc. This is milliamps, and that's 10 amps. And then as we work our way around there's the various settings, that lights that come on, give us the various arrangements. So I'll get set up with some components, and we'll just check out how this reads on its various settings. Okay, here we are back then, and so first of all we'll switch on, and we'll go straight to resistance, and I've got as usual I've got a selection of resistors here. So this is a fairly low value one. Let's see what we get, and fairly quickly it's identified that as well, it's 68 ohms, so we're on the auto range here, so it's not took it too long to get there. So we've got a sort of a middle of the road type value here. This is 120k, didn't take very long to get there either. And finally here we've got 8.04 mega ohms. Yeah, and it's within 0.3 of a mega ohm there, so that's pretty good. Let's go back to the low value one again, and yeah, it's quite nice and snappy as it gets there. Now on the ohms range, when you step through these ranges, you get different menus here. So you've obviously got relative there, but the other thing you can do here is you can, if there's a choice of modes, there are 3 here, so we can press F3 to select. That takes us to diode, it takes us to continuity, and then back to resistance, as it clearly tells you at the top. So I'll just pop to continuity, because quite often these meters are a bit slow on the uptake, and this one isn't too bad. So if I tap that, we're getting an audible indication, but we're also getting the red light coming on the top. So in a noisy environment you'd still be able to see that there was continuity. And if I now increase the speed, most of the time the sound keeps up, but the LED certainly does keep up on the top, so that's pretty good for a meter at this kind of price point. So let's now step back through to diode, and I've got a couple of diodes here. It's got a 1N41480 or 4001, can't remember which, and quite correctly it's identifying it as 0 there, because that's reverse biased. Let's do the same for the yellow LED. Yep. So if we swap the leads around, we should now be able to see the forward junction voltage of a silicon diode, 0.633 volts. That's pretty good. And let's see what a yellow LED does. It should light it up, about 1.875. So yeah, that's, I quite like that. It's quite nice and snappy. So yeah, right, let's go to capacitance, and I've got 3 levels of capacitor here. So I've got a 330 nanofarad here, so let's pop the leads onto there. Fairly quickly gets that as about 313 nanofarads. That's pretty good. Got quite a big electrolytic here. I think it's 220 microfarads, and after a moment or two, yeah, nearly 213 microfarads. And what I quite like is that it says microfarads and not point something millifarads, which some of them do. Let's go back to the 300N. Yeah, it's gone nicely back to N. Now a tough test here. These are some quite ancient ceramic discs of about 50 or 60 picofarads. So let's see what it makes of that. Yeah, so it's saying 74 picofarads. Hopping back onto the 330 again, make it jump about its auto range, and then back to the 70 odd picofarads. Yeah, that's pretty good for resistance, capacitance and diodes. Yeah, quite impressed with that. Right, I'll get set up for some other readings, and we'll see how it looks. Okay, I don't have any fancy calibrated voltage sources or anything like that, but what I thought might be a good idea is to compare it with something which is probably considered to be the competition, and that's the Zoe ZT702S, which if you've keen watcher of the channel, you've seen this before. And these are both similar. Bear in mind that the Gochifix doesn't actually have a BNC input for the scope, so it's obviously going to be a bit of a challenge to get good quality signals along a pair of unshielded leads, which I think is quite understandable. But just to compare the meter functions, let's now power up both instruments like so, and we'll power up the Zoe, and I've got them both on auto ranging, set to millivolts, and all I've got is them connected up to my bench power supply, so it isn't calibrated, but we'll start off at something around 1 volt and just see how they compare. Yep, they're within about 1 millivolt there. So if we just wind up the voltage a bit to around about, I'm just guessing here really, around about 5 volts, something like that. Yeah. And again, both agreeing within, both agreeing within a few millivolts. If we go up yet again, the maximum this bench power supply does is about 15. And again, we're within about 3 millivolts there. Now I've got another bench power supply, so I'm going to swap over to that, because that will actually do up to 30 volts. So let's just see if we can achieve that. It's not on anything like 30 volts at the moment, but it's probably only about well, that's about 5, yeah. So if we go up to, and there's your 15. Right, so now I'm going to go on to the next range, which should give us quite a bit more. So let's try up there. We'll let them just stabilize about 23 volts, and then the most I can get out of my bench power supplies, actually if I turn up the fine I should get a little bit more. So yeah, about 30.5, so within 100 millivolts of each other there. So yeah, certainly seems okay on DC volts. Okay, so now I've got both meters attached to the best I can do in terms of a bit of a variable AC source, and that's one of the channels on one of my signal generators. I don't have a fancy AC power supply, so currently I've got it set to 1 volt on the, well, that's what the signal generator output says, and as you can see, both meters are agreeing within 1 millivolt, get my words out, that it is indeed 1 volt RMS. So if I increase that to 2 volts RMS, yeah, and they're still within millivolt of each other, and probably can't go much more than that without it squeaking at me. Let's try 4, yeah. So that's AC volts for you, and if I pop through select, it should pick up the frequency, which indeed it correctly does at 49 Hertz. Now if I swap the mode here on the Zoe, well, I'd quite like to swap the mode on the Zoe, but it doesn't want to play at the minute. But if I swap the mode on the Gochifix, if I now hold down auto for 2 seconds, it'll drop into the oscilloscope view. Now it won't work on the Zoe because it requires the input to be on through the BNC, because it's got a probe in the conventional sense. So once we're into oscilloscope mode here, and I will have a look at that a bit more in a while, but if we now press F2 and go to volts, that allows us to increase the sensitivity, so we can actually see we have indeed got a waveform. And if we exit from that and go to time, we can then tweak the time base a little bit, so we can see we've got a sine wave there, and it's correctly identifying it at, well, 3.97 volts RMS and 50 Hertz, which is what I've got the signal generator set to produce. So yeah, again, AC volts seems absolutely fine. Okay, let's take a better look at the oscilloscope function. So I've got the meter attached via its conventional probe leads to the signal generator, and currently the signal generator is producing 10 kilohertz sine wave, and that's indeed correctly identifying it as 10 kilohertz. So let's just increase that frequency. In fact, let's step up to that's 50 kilohertz, and if we use the, I've got it set to time here, so these two buttons will now adjust the time base. So if I go up to, let's say, 100 kilohertz there, and that's 200 kilohertz. So what I'm now going to do, just to see how feasible this is, I'm going to slow down the time base so we get just a solid, if you like, block of a display there with all the sine waves squashed up to each other. And I'm just going to pop modulation mode on the meter just to see if we can view amplitude modulation. And yeah, we actually can. Let's just tweak that a little bit. Yeah, there you go. I've got modulation there, 100%, at a frequency of 500 hertz, and yeah, so it's actually managing to show you the modulation envelope, which I was sort of not really expecting, but yeah, it's doing all right, isn't it, that? You know, bear in mind this is a multimeter with just bare leads, and I'm effectively feeding in 200 kilohertz now. Okay, let's turn modulation off and let's go back to a slightly more sensible time base. We can see a couple of waveforms, and let's now whiz the frequency up. That's 1 megahertz, and again we can still increase that. There's the maximum on time base now, so that's 1 megahertz, and don't know how well you can see that, but it is indeed identifying it as 1 megahertz. So let's go up to in megahertz steps now. So that's 5 megahertz, and I can't increase the time base anymore, obviously, or speed up the time base, I should say, but we can still see a waveform that is correctly identifying it as 5 megahertz. So let's be really brave and go up to 10 megahertz, and okay, it's still showing a waveform, difficult to see the shape, but it is correctly identifying it as 10 megahertz. And considering that 10 megahertz is serious RF, and that's just coming through a pair of completely unscreened leads into the meter, that's probably not too bad. If I keep on going up to well, I'm up at 15 megahertz there, and as you can see, it's clearly it's struggling now, understandably, but that gives you some idea of what it's capable of. Let's go back to 1 megahertz sine wave, and I'm going to tell the generator now to give me a square wave, and not surprisingly we've got lots and lots of if you like, ringing noise at the start and the finish of the corners of the square wave. That's almost certainly a function of the fact that I've got completely unscreened leads, I would imagine, but there is a semblance of a square wave there. I think that's probably a fairly harsh test for something that's just got a couple of open leads as its supply. So yeah, that's the oscilloscope. Let's see what it makes of a ramp wave. Yeah, it's making a better job of that. Let's try and up the frequency a little bit. Let's go up. Now the maximum I can get there, I'm afraid, is well, that's 500 kilohertz on a ramp wave. Yeah, so it's not doing so bad, really. As I say, you know, completely unscreened leads, it's not surprising it's struggling a little bit. I don't think I've got anything that's screen that goes to banana plugs. If I had, it'd be worth trying it, but yeah, it's interesting. Does occasionally settle down, doesn't it, and not show the ringing. So yeah, there you go. So I think you know, what you have to bear in mind here is it's a little multimeter, and I think if you're starting out in electronics, this would be amazing. You know, amazing to view waveforms. Many years ago I had a Velman, I think it was a HPS 10, and that was a little LCD display oscilloscope, and I was delighted with it, and actually it was completely rubbish compared to this. So, you know, again, the march of technology has given us something which we certainly wouldn't have had in the past. Okay, and just to finish off looking at the scope functions, I didn't particularly explain this when I got it hooked up to the signal generator, but you can F3 takes you to the trigger menu, which gives you choice of leading and trailing edge. The display changes there. You probably struggle to see that, to be fair, on the camera. And also there's AC DC coupling, so it allows you, if you want to view whether or not there's a DC imposed on an AC signal, that kind of thing. And having done all that and talked about the multimeter, etc., this button here that's got a sine wave on it duals up as the brightness control, but if I do a long press it takes me to this menu, and if I press wave I've got a choice of sine, square and ramp, and then if I change the frequency there, I've got a choice of frequencies from 100 Hertz, 200, 500, 1 kilohertz, 2, 5, 10, 20 and 50 kilohertz, and 3 waveforms, and this is actually a signal generator. So you connect your probe, leave the common in common, you connect the red lead to there, and then that will output this signal on the two probes, if you like, for the meter. Not explaining myself terribly well. So I thought, well, I wonder if you can use both that and the scope at the same time, because it'd be very handy to be able to inject a signal into something and then look at what the circuit was doing to the signal. So that was potentially a useful little thing, and I wasn't sure if it would work. So what I've done here, I've just got a banana plug to banana plug lead, so I'm going to plug that into the signal gen output, and I'm going to plug it into the probe positive, which effectively is the scope input, and then we've got a 1 kilohertz ramp wave there, sawtooth wave there. So we'll now do a long press on the, and as you can see it does indeed show you, it does indeed allow you to generate a signal and also to use the scope, which actually, considering what you've got here, I think that's quite remarkable. And if I do a long press on there, take me to the signal gen again, we had a ramp wave there, so let's go up to a sine wave, and then we'll do another long press on the scope button, and as you can see, yep, we've got a sine wave. So yeah, it's when I was doing a review recently, I referred to the instrument as a lab in a box, and you've got the ability here to measure volts, current, resistance, capacitance, frequency. It also does microamps, although I've not been done any of that, and as well as that you've got a scope and a signal generator. Now you might want to say, well, yeah, but it's limited, you can't have infinitely variable. Okay, agreed, but it does allow you, for instance, to vary the waveform, the frequency and the duty cycle, and actually there's enough there to allow you to you know, play with some audio frequency stuff and perhaps learn about amplifiers and things. So yeah, I quite like the idea of that. Yeah, very nice. Okay, well that's it for a look at the Gochifix Scope Meter, multimeter, oscilloscope, signal generator. Quite a lot in there for a small package, and yeah, I think it's alright if you've got nothing else, and you're trying to do electronics on a budget. That's potentially a very handy tool. I will do another video at some point where I'll actually try and use it along with just a breadboard and a few components, and we will see what it's capable of, but that's for the future. If you like what you've seen and you fancy one, there is a code in the description. I think you get 25% off. It's only for a limited time, but it is there. I don't make anything out of that, nor do I wish to, but it's there should you decide that that's something that you might like. So thanks very much for watching, and look forward to seeing you on the next video.